Hello friends. So in this lecture we will look at graph representation using adjacency list, and here the difference is that the graph is now a weighted graph. Okay, so last time we saw that we could very easily represent so this graph, and so because we just had 0, 1, 2 and 3, so this was the graph, and we said that we could represent it using adjacency list with 0, 1, 2 and 3. So what we did, so we said that okay, with 0 your 1, 2 are connected, with 1, 0 and 2 are connected. Then for 2 it was 0, 1 and 3 all are connected. For 3 it was just 2 was connected. Okay, so this was a vector and there was a list for each item of that vector. But here the thing was that each edge was the same. Okay, so there was equal weight for all of them. Okay, we were not distinguishing if there is an edge, it's an edge. Okay, so there was no difference. But now let's say someone says that each of the edges are weighted. Okay, a weighted graph. So this is, let's say, something like 4, you have here 5, here a 2, then here a 1. So now if you just represent like this, so your basically your representation will not be complete. Okay, it will give information, but that will be just saying that okay, there is an edge between 0 and 1, there is an edge between 0 and 2, but it will not tell what is the weight of that edge. So we need to do something more. And what we do, so now instead of just having the nodes there, so you need to also define what's the weight of node of that edge. Okay, so we need something more here in this part in the list. So I was just having an int here saying which node I'm connected to, but I also now need one more information, that is what is the weight of that particular edge. And that's what we want to accomplish here. So let's see with the code. So it will be very similar to the last one, only difference is here is now we have a class. Okay, so we have a class called edge where it tells what is the weight of that edge. So weight is the double, and then I know that okay, what is the starting node of that edge, so what is the end node, I know, use the vertex ID to represent that. Okay, so we have now the weight plus the node. Okay, so that will tell me the complete information, and I have a constructor which takes double weight and integer ID to get that information. We have get weight and get vertex IDs are two methods that give you the weight and the vertex ID for that particular edge. Again, it is the same thing. We now need to represent. Okay, so let's see. So we have again a vector. So vector of what? Lists. But the thing is that now our list is not just an integer telling what are the nodes that are connected to this particular node, but it's the edge class itself. Okay, so it's the edge class, and we make adjacency list and equal to size of the graph. Okay, the number of nodes in it. So now when we are done with this, again, now when you are making the graph, you just need to do, so we are making here a simple graph. So 4 edges, 4 nodes are there. Okay, so 0, 1, 2 and 3. So now let's try to see how they are connected. So 0 to 1, so adjacency list 0 means the, now we are this part again from the previous lecture. So this is our list, the pointer to the list. Okay, so this is the list basically, and we do adjacency list 0 dot push back. So this is the object, the list object, we do push back. So here we now get an edge. So in that edge the weight is 4 and it is connected to 1. So 0 to 1 is one edge and its weight is 4. Now what we do, push adjacency list 0. So in this list itself, so we also will make here 0, 1, 2 and 3. So now what happens, edge 4 comma 1. So here we have 4 comma 1. So this is the 1, and 2 comma 2. So now we also in this list, so 2 comma 2, which means it is connected to 2, 0 is connected to 2 and with weight 2. Now adjacency list 1 dot push back edge 4 comma 0. So 1 is now connected to 4. Okay, so that's the same thing here. So 1 is connected to 0 with weight edge. So this is there, but here I need to draw it. So it is 4 comma 0. Now 1 is also connected to node 2 with weight 5. So this should come here. So 5 is the weight, it is connected to 2. 2 is connected to a lot of other nodes. So 2 is connected to 0 with weight 2. Okay, it is connected to node 1 with weight 5, and it is connected to node 1. Okay, so to node 3 with weight 1. This is done. Your 3 is very lonely, it is just connected to node 2 with weight 1. Okay, so this is now our list. Okay, so we have this vector and this is our list inside those vectors item. So this is there. So we also have here, so 1 is the weight here. So now that's good. How to iterate again? So this is again how will we iterate. So we will iterate basically, again we have iterator for the vector we should have and iterator for the list we should have. So we will, in each vector we will iterate. Here we will go this side. For each of the elements of the graph, each node of the graph, we will go with the iterator to the vector. In each of these items, while iterating, I will find a list. Okay, and we will again iterate through that list. So we iterate here, then we go down, iterate here, go down, iterate here, finally we come here to the end and iterate here. This is the basic idea. So how we do that? So we have here, so a vector which is a list of edges and its iterator here, that iterator is I. Int c is 0. So vector standard list edge iterator I. So we start with adjacency list dot begin I till it's not equal to adjacency list dot end, till I don't reach here, increment. Okay, so we iterate further. Here what we do, vertices connected to node, that C node which we are traversing now. So let's try to see what happens. So here we come. So I get, when I'm in that particular node, I will want to get that particular list. Okay, some accessibility to that list that I get by star I. So I was the pointer, so I get star I, which gives me the list in that particular node of the neighbors. And then what I do, so that list is of list of edges. I make one iterator of that list of edges. I start from the beginning, I iterate till I'm not at the end, and then what I do, star iter is how you will access the element. So star iter, you get that edge object, and dot get vertex id, you will get the vertex at the end, the neighbor vertex, and what is the weight, you will get star iter dot get weight. So this is how you will get weight, and we iterate here. So let's try to build this code and see what happens. So we have vertices connected to node 0. Our v is 1, weight was 4, v is 2, weight is 2. So this way you iterate and go. Okay, so this was about a graph representation in adjacency list form with the weighted edges. And one simple extension of that is that here we can simply, okay, we can have what is known as directed graph, can also be very easily handled here. Okay, in directed graph, what happens if you have again the same kind of graph here? So what happens is that these edges, so 0 to 1 might be having some different weight 3. If I come from 1 to 0, it might be having a weight 5. Okay, so that edges, they are directional. 1 to 2, if I'm going, let's say its weight is 4. When I'm going from 2 to 1, it's something different. Might be, they might be same also, but they might be different. Okay, so that is, they are not the same in both the directions. Okay, that's the basic idea. So in that case, what we will do when we are doing adjacency list 0 dot push back, so for 0 when I am doing to 1, so I will push back, so 3 comma 1, here it will be 3 comma 1, but when I am doing 1 push adjacency list 1 dot push back for 0, it will be a 5 will be here. So they are now different, and that's how you will handle a directed graph. So I hope you understand this. Thanks a lot.